Welcome back to my channel, everyone. Sweet Tips here. What I have is some gold-filled scrap that I've accumulated, and we're going to get a weight on this. Should be about half a kilo. Okay, we've got 502.1 grams of gold-filled scrap. What we'll do is incinerate this before we get started. I just wanted to show you a couple of the markings here. That's how you can tell this piece is gold-filled. If you get a pocket watch and it says warranted or guaranteed 25 years or 20 years or 30 years, that means it's gold-filled. Here's another marking. Let's see if we can find it on here. Gold filled, 14K gold filled. Here's a gold filled bracelet. 1/20th, 12K GF. That's gold filled. The whole bracelet is gold filled. The charms are gold filled. They're marked GF. And this is valuable material here, but people don't think it is. I think I paid $6 for this thing. Gold filled material will yield about 2.5% to 3% pure gold, which means for every 100 grams of gold filled scrap, you should get 2.5 to 3 grams of pure gold for every 100 grams of gold-filled scrap. Let me see how much this thing weighs. That's 14, and we got 46. So what's that? About 30. That's about a gram of gold right there. So that thing's worth $70, because a gram of gold right now, pure gold, is about $70. Here's another piece. I couldn't find any markings on it. And so the way to test pieces that don't have markings is to just take a little bit of the 14K testing acid like this. And if it just sits there and does nothing, it doesn't bubble, it doesn't turn green, and it doesn't start to stink real bad, then chances are high that you have a piece of gold-filled material, because gold-filled material is a thick coating of karat gold over brass. If this was gold-plated, that drop of acid would have turned green, started bubbling, and stink to high heaven almost immediately as soon as I put it on, because gold-plated material is just a few microns, thinly coated gold over a junk metal. And this piece has not reacted, so that tells me that there's karat gold over brass. This is a gold-filled piece. I wiped the acid away. There's no mark where that acid was sitting. That verifies, tells me that this is a thick coating of karat gold over brass. This is gold-filled, and I can add it to this this batch of scrap. All right, these pieces, these bangle bracelets, usually has it on the inside here somewhere. These things got a thick coating of gold. They're very rich in gold material. I'm trying to read it off the screen. 14K, 1/20th, 14K GF. So this is a nice piece of gold-filled stuff here. It'll be high yielding. Someone had asked about these watches. These cases are going to be gold-filled. And if you look on the back here, it says 10K rolled gold plate. And what that means is they take a piece of brass and a chunk of karat gold, heat them up, and they roll them through a roller and bond the gold to the brass. So this is gold-filled material. It could say 10K RGP, or in this case, it says rolled gold plate. All right, one more piece just to show you what we're looking at. This was a watch band, 1/10, 10K, GF. Well, once again, gold fill material is a thick coating of karat gold over a base metal, usually brass. This will test positive. If you rub this on a touchstone and put some acid on it, it will test positive for karat gold. That's because it is karat gold, a thick coating of karat gold over brass. So don't be fooled by the acid test. This will test as solid karat gold. And if you don't know what you're doing, you'll pay for solid karat gold and end up with a gold filled piece instead. All right, let's put the rest of this in this melt dish. We'll take it out here and incinerate this, which is the first step in the recovery process. Incinerate the gold. All right, we got 502.2 grams of gold filled scrap. I'm gonna take it out here now and we're gonna burn it. Here we go. Take some of this out of here. The pan's too crowded to try to burn it all at once. I'm gonna start this off by adding some distilled water to a clean beaker. I've split the gold-filled material into 2 groups so that I don't crowd the dish. Now let's add this to the beaker up here. Come down, put the next group in the melt dish so we can burn this now. Now let's add this to the beaker. Put our beaker up on the heat source. I'm going to fill up this separatory funnel with ½ liter of nitric acid. This reaction takes about 3 milliliters of nitric acid per gram of gold-filled scrap. So we're looking at 1.5 liters of nitric acid to get all this base metals pulled out of here. Now what we'll do is start dripping some nitric acid down into our reaction beaker here, and this will dissolve out the silver and the base metals from this gold-filled scrap. First 500 milliliters of nitric acid went into the reaction without incident. I'm adding ½ liter of water here. Water is necessary to provide a medium for the base metals to dissolve into. Now what we'll do is we'll take the nitric delivery apparatus out of here, recharge it, and put in another 500 milliliter dose of nitric acid. I've got 1 liter of nitric acid in on the gold-filled stuff here. You can see the material starting to float up top. That's because it's bubbling inside, reacting with the nitric acid. That sends it to the surface, so it floats. And so now what I'm going to do is put this on a time lapse on another camera. We're just going to let this boil until all of the fumes are gone out of that beaker. That will tell us that all the nitric acid that I've added so far will have been consumed. I think we've gotten all the mileage that we can out of this nitric acid that we put in here. So what we're going to do is pull this down off the heat and let it cool. Rod, take a look at what we got going on in here. Oh yeah, look at that. Look at those beautiful gold foils. That is gorgeous. I can still feel some solid material down in there. So we're probably going to have to add a little bit more nitric acid to get the rest of the base metals out of here. But that's our gold foils. That's our prize right there. Let me rinse down the sides of this beaker with some distilled water. And what I want to do now is kind of dilute this just a little bit. And I don't want to add too much liquid to the solution. It's going to contain a little bit of silver, so we want to save it. But what I'll do is I'll try putting some ice in here in this big container and getting the solution to cool down in an ice bath. Solution is cooled. I wanted to cool this before I tried to filter it. It would cause the filter paper to fail if I tried to filter it while it was still hot. So now what we're going to do is try to pull this up this blue solution through this filter. Here we go. It's taken several hours to get this liquid pulled through this filter. But you can see the gold foils now down inside the beaker. They are looking awesome. And what we'll do, now that I've got all the liquid off of there, go ahead and put some more nitric acid on there and see if we can extract some more of the base metals from these gold foils. I'm still waiting for this solution to pull through the filter. So while we do that, what I'll do is add some distilled water to our gold filled material. That's about half a liter. Now that most of the base metals have been pulled from this scrap, I'm just going to go ahead and add half liter, 500 milliliters of nitric acid. Now what we're going to do is cover this up, set this back up on the heat, and allow this to react and get all the rest of the base metals pulled out of this gold filled material. I think I'm going to hydrate this a little bit so that it doesn't get dehydrated as I allow this to react. So I'm adding about 300 milliliters more distilled water. What this should do is this should be enough nitric acid now to just about pull every bit of the base metals out of our gold filled material. I've had this on boiling in dilute nitric acid now for hours. So reach down in here and see what we got. Oh yeah, look at that. It's all in little bitty pieces. It's all kind of falling apart. Some of the stuff is still in the shape of what it used to be like. Turn off the heat and let this cool down. Chilled the solution. You see there's still plenty of base metals coming out of that material. I've got the filter, all the solution pulled out of this filter and down in our flask. So what we're going to do now is take this filter paper. This is going to be gold mud. Put that in a melt dish down here. I've got another filter here. Down in our funnel, and now we're gonna filter off this liquid. I've cooled it down, chilled it with some ice, and we're gonna pour this off now into this filter. Get our gold mud and gold foils out of this beaker. Here's our gold foils down inside the beaker. And what we're going to do is run it around the bottom of the beaker. See if there's anything magnetic in here at all. See a little piece right there. It might be a piece of steel spring or something. But I don't see any other movement in here. I might as well go ahead and get in here and get this and see if I can get it out. See what it is. It's a steel spring of some sort or something from one of the pieces. You can see where the nitric acid has dissolved it a little bit. Nitric will dissolve iron, but it doesn't do it very well. So we'll just take this out and exclude it from this batch of gold-filled scrap. I'm transferring the gold foils down into this filter. Here's our recovered gold foils in this filter here. Looks good. I take my other filter, put it in here. Now we'll take this all out carefully. I'm going to put this whole thing into a crucible and burn it. This solution in this flask is going to have some silver in it. It's probably also going to have some excess nitric. So what I'll probably end up doing here is adding some sterling silver to consume the excess nitrate that might be in here, and then we'll recover the silver once all of the excess nitric has been consumed. Now we're going to take our material out, put it in the furnace, and incinerate all the combustible material out of here. Let's get in here and see what it looks like. Oh yeah, look at that. I think it's already, that's done, man. I'm gonna take this in now and process it. I've allowed this stuff to cool completely. And what we'll do now is add the incinerated gold foils to this beaker. Dump it right on in. I'm going to add some hydrochloric acid. I'm going to add an excess amount, way more than I need. That's about a half a liter of hydrochloric acid. Now we'll transfer this up, set it up here on the heat, and begin heating it. Excess amount of nitric acid as well. Here we're going to measure out about 40 milliliters, which is way more than we need. What I'll do is I'll dump that in and put it on time lapse. Let this reaction go. Gonna take this off the heat, let it cool down. down to about ambient temperature. Just going to add a few ice cubes here. Cool it a little further. Look at the bottom of the beaker there. Got some metal left over. Might be some karat gold. That happens sometimes. Here's a look at the metal down in the bottom of the beaker that did not dissolve in the aqua regia. That could be some gold. Could be some platinum group metals even. Sometimes they use karat gold to make embellishments for gold-filled material. I've seen it before. So we'll get that out of there, test it, and then I'll throw it in with my next batch of karat scrap. Here's what's in our filter. Little piece of gold there. Pick that out. Precipitate gold with some sodium metabisulfite. Get it out of this green liquid. I'm expecting 12 to 15 grams of pure gold. So it should only take about 2 or 3 spoons of SMP. Status test before we did this precipitation, which I should have done. Maybe one after. You can see by that negative status test, all the gold has been precipitated. Let's get this solution poured off of here. It's looking pretty good. Expecting 12 to 15 grams of pure gold from this batch of gold-filled scrap. We give this a few water rinses to get the chemicals off. Now what I'll do is add some hydrochloric acid. We're going to set it up on the heater and give this a quick boil. Hydrochloric acid. Add some hydrochloric acid to the gold. Back up on the heat. Add a little dribble of sulfuric acid. Get any lead out that might be in there. A couple shots of nitric acid. Should only take about 6 milliliters of nitric to get this to go in the solution completely. Now let's make it 3 milliliter doses, 9 milliliters of nitric acid. got all the fumes to clear up in there. We've got it evaporated down. Those fumes are gone. We can conclude that all the nitric, excess nitric, has been driven off. Down, let it cool off. I'm going to pass this through the same filter a second time. See if we can get it to clear up a little bit for us. I've got this SMB that's been filtered, this beaker right here, but I don't know how much is in there. I'm going to try pouring dissolving the SMB and filtering it. I don't know if I got enough down here or not, so I'm going to make some more. Just dissolve it in some distilled water. Filter it. Let's transfer our gold solution out of here. Here's our filter. Look too bad. That out of the way. We'll put our gold solution in a clean beaker. Second pass to the filter, cleaned it up nicely. Got our SMB filtered. So what we'll do now is add it to the gold solution. Test it with Stannis again. That's okay. We know there's gold solution. That's pretty much got it all. Make sure with a Stannis test, make sure we got everything precipitated. But you can see all the gold has come down. Let's go ahead and put our gold up here on the heat. We're going to try to get it to settle quickly by boiling it. That cleared up pretty quickly. I'm going to pour this waste solution off, give it some rinses, and then give this a boil, hydrochloric acid. right, this is gonna be done boiling in hydrochloric. Pour this off now into our waste container. Adding some distilled water. I'm gonna boil it up here with a little bit of distilled water. Just take it off this water boil. Our pure gold sponge. It's looking real good. Let's get our gold in a melt dish. Take this over to the melt table, melt an ingot. Here we go. Skin on it. Put some potassium nitrate. A pinch of borax. Pour the ball. Here we go. Try it again. Although it don't look too bad. Came out pretty good that time. see my reflection. That's how I can tell when I got a bar of pretty pure gold, is when I can see my reflection in there. Here's the stuff that did not dissolve. We're going to take that off of our yield, or off our starting weight of our material. Looks like it's 5.1 grams. So we started out with 502.2 minus 5.1 equals. So we got 497.1 for a starting weight. Now what we'll do is weigh up our little bar that we just poured. It's gorgeous, most beautimous. We're expecting 12 to 15, and we got 16.3. So 497.1, 16.3, we got 16.3 divided by 497.1 equals. We got 3.2% from our gold-filled scrap. Got us a nice little ingot out of this refining. It is beautiful. All right, that'll conclude the video. I'd like to thank everyone for watching.